Pythagoras' theorem, a fundamental principle in geometry, posits that in a right-angled triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides. This relationship can be mathematically represented as c superscript 2 equals a superscript 2 plus b superscript 2, where c is the hypotenuse and a and b are the other two sides. To comprehend this theorem visually, imagine a right-angled triangle within a space where each side is extended to form squares on them. Place one square at length, another at b, and a larger square at c. The distinct areas of these squares immediately depict the theorem's assertion. For a clearer visualization, consider constructing this geometric arrangement using dynamic software or physical manipulatives. Start by drawing the triangle, ensuring it's right-angled. Next, draw squares on each of the triangle's sides. Observe how changing the lengths of A and B will affect the dimension of the hypotenuse square. Exploring the visualization further, utilize colors to highlight the relationship between the total area covered by squares A and B compared to square C. Shade squares A and B in cooler hues like blue and green, and square C in a warmer hue like red. This allows one to see how these distinct parts contribute collectively to the theorem. In an engaging classroom activity, use cutout cards resembling squares of each side on a large board. Arrange them to see if they accurately cover the square on the hypotenuse. Similarly, advanced visualization tools such as vector graphics software can be employed to animate how these squares transform, reshape, and validate Pythagoras' proposition dynamically. By reinforcing the concepts through visual aids, the understanding of Pythagoras' theorem transcends mere mathematical equations, gaining a tangible form that students can explore, manipulate, and internalize.